All right, everybody, let's get started on reviewing for your Unit 6 Part 3 quiz. Make sure to have your notes open to help you through your homework as well as your quiz. It's going to be really, really helpful when you are taking the quiz. So I'm going to go ahead and open that up. So on this screen here, I have my little anchor chart that has all the different parts of the equations and how they change the parabolas and kind of how to identify each different piece. So we can use that when we have certain problems, like the first one we have here. It says, if the parent function was f of x is equal to x squared, describe the transformations that happened in the equation. So there's obviously a lot of new things that are going on here. I have this negative 1/3 that was added in. I have this -2 that was added in. And then I have this -4 that was also added in. So let's start with that negative 1/3. So if I'm looking at my equation here, it says that the a changes the parabola in a variety of ways. So if it's a fraction, which is what we have, right, 1/3, so that's going to be, it says here, a vertical compression. So let me just go ahead and find, here we go, vertical compression. The other thing we notice about that 1/3 is that it is negative, and it says if it's negative, the graph is going to be an upside down U. So the graph's going to reflect. So we have that. Okay, and then we have our -2 in there. So that's, we see here the h value moves the vertex left or right. So if I have x -2, which is what I have in here, right, -2, that's actually going to move the graph to the right. So subtraction goes to the right. So we are going to translate 2 units right. And then finally, we have that -4, and in my equation, that's plus k. In this case, it's a minus. So let's see what it says. If we have a -k, the graph is going to shift down. So we are going to say translate 4 units down. All right. Pay attention to how you need to type in your answers to make sure that you do that correctly, and that's not why your question is being marked wrong. Listing the letters separated by a comma and no spaces in alphabetical order. So that would be B, C, D, G. And that should be all of the problems for number 1. Our next problem, okay, we have some new things here as well. I have a 2 out in front. I have a +3 and a -7. So if we have a 2, or if the graph is greater, if the a is greater than 1, this is going to be a vertical stretch. If I'm adding in my parentheses, I'm going to the left. And then again with my k, if I'm adding, I am moving up. So I'm going to have a vertical stretch. I'm going to go 3 units to the left, and I'm going to go 7 units down. So we actually have A, E, and G for the second problem. Which of the following functions is the narrowest? So a graph is more narrow if a is greater than 1. So I'm just going to look for the graph that has the largest a value. And it is y is equal to 8x squared. Now, this can be an a value of 8 or -8. The positive or negative doesn't affect how narrow it is, okay? So I know we say greater than 1. We really just mean like the absolute value, or the digit is going to be greater than 1. So it says that the original equation was y is equal to x squared. What would the new equation if the function was vertically compressed by a factor of 1/2 and translated 5 units to the left? So if I want to do a vertical compression, I'm going to make my a. I'm going to change my a. And then if I want to go to the left, I need to add inside my parentheses, right? So, I'm sorry. I need to add inside my parentheses. So I'm going to start with my y equals, but now we have a factor of 1/2 x, but then in our parentheses, we're going to have x plus 5 squared. So now I can see that I have that vertical compression and the 5 units to the left. Okay, if the parent function was f of x is equal to x squared, describe the transformation in the equation. So we know that the parent function always starts at 0, 0. If I were to substitute in -1 for x squared, I would get -1 1. And if I were to substitute in 1, I would get 1, 1. So this would be the original parent function. And this is our new function. So our new function has a new vertex that's at -2, -3. So I know it went 2 units to the left, 3 units down. It didn't reflect because a reflection would look like this, right? Our U would be upside down. And the stretch and the compression, well, let's look at these 2 points. They are 1, 2 spaces away from each other, just like the original parent function is 2 spaces away from each other. So it didn't compress, it didn't get stretched, it just translated left 2 and down 3. So I'm going to say E and G. Okay, so it says that the quadratic function h of t is equal to -16t squared plus 64. This can be used to approximate the height t in feet above the ground of a falling object t seconds after it is dropped from a height of 64 feet. What would the height of the object be after 1 second? So I'm trying to think in this equation, what letter or variable or what is standing in for time? It's going to be t, right? So I want to know the height after 1 second. So h of 1, or the height of the time, the height after the time. In this case, the time is 1 second. So I'm going to substitute that in for t. So I'm going to have -16 times 1 squared plus 64. And when we do this, we're going to get -16 plus 64, which gives us 48. So our height is 48 feet at this time. It then asks us how long it will take for the object to hit the ground. And this is when we just take our equation, our -16t to the power of 2 plus 64, and we set it equal to 0. And then I'm just going to solve it using inverse operations and solving by square root. So I'll start by subtracting 64 to get -16t to the power of 2 equal to -64. From there, I'm going to divide by -16. I will get t to the power of 2 equals 4. And then I will just take the square root, and I will get that time is equal to 2 seconds or -2 seconds. But obviously, we cannot have negative time. So that's how we will get an answer of just 2. Okay, so next thing we're looking for is our vertex. Our vertex is the point where our graph meets up. So this is going to be our vertex right here. We're going to be at 1, 4. Remember, this is an ordered pair, so we have to write it as such. Do we have a maximum or a minimum? So let's go ahead and actually look at our anchor chart. Okay, maximum or minimum. A graph is a minimum when A is positive, or the graph opens up like a U. So I see that right there. It's a maximum when the graph reflects. That's when it's upside down. So this graph is actually upside down. So this is a maximum. And that maximum or minimum value, what does it say here? Is the y of the vertex, or the k. So the y of our vertex is 4. So our maximum value is 4. The next thing we have is the axis of symmetry. It says that the axis of symmetry needs to be written as an equation in the form x equals. So we need to set x equal to the x value of the vertex. So our vertex is 1, 4. So my axis of symmetry needs to be written as x equals 1, because our x value is just 1. The zeros are where we cross the x-axis. So we cross the x-axis at 2 points, and they are at -1 and 3. That's what we get when y equals 0, or equation equals 0. And then lastly, we have our y-intercept. And our y-intercept, just like in the start of the year, is where we cross the y-axis. And on this graph, we cross the y-axis at 3. So the y-intercept is 3. That is how you find all of those things looking at a graph. So it's a little bit easier when you're looking at the graph. When you come to the equation, that's when it becomes a little bit more difficult. So you just have to make sure to use your anchor charts. They will help you. So the first thing we have here is, what is the vertex? Well, our anchor charts say that the vertex is the opposite of h, comma, k. So we have h is inside the parentheses and k is on the end. So whatever is inside the parentheses, we have 4. So we're going to use the opposite of h. So the opposite of 4 would be -4. And then we have just k, and k stays as is. It says that on our anchor charts. K stays as is. So if k is negative, it's going to be negative. So we have a -1. It's going to stay a -1. Does the function have a maximum or a minimum? We just talked about this. If the graph, if the a is positive, then it is a minimum. So in this case, we don't see an a value there. That just means, it is a positive 1. So we are going to say that this is a minimum. What is the minimum value? We talked about how that is going to be your y of your vertex. So our vertex is -1. So it's going to be the -1. The axis of symmetry, we just said, is x equals our x coordinate, and the x is a -4, so our x equals -4. And then to find the zeros, we need to set the equation equal to 0. So we're going to have x plus 4 to the power of 2 equal, or -1 equals 0. Start by adding 1 to both sides. X plus 4 squared equals 1. Square root both sides. X plus 4 equals 1. Or we can have -1. We're going to subtract 4 from both, and we will get x equals -3 or -5. We're going to solve by square roots, and then the y-intercept is what we get when we set x equal to 0. So our equation would become 0 plus 4 squared minus 1. So I'm looking at my original equation, x plus 4 squared minus 1. I am substituting in 0 for x. So that would give me 4 squared, or 16, minus 1, which would give us 15. That is it for your first review day. Hopefully you can use that review to help you solve the rest of the problems. They are all very similar, and you can use how I modeled it in the first half to finish up this assignment on your own so that you are prepared for your quiz. Again, make sure you have your anchor chart out or your notes, whatever it is, so that you are getting practice using your resources and knowing where to find things. And good luck on your quiz.